Okay, so let's start with the Seaborn. Now, this is a very useful library available with Python, and it is for visualization. So let's start and let's understand what is Seaborn. So Seaborn is a subset of matplotlib. Matplotlib and Seaborn are complementary to each other. So that is why both of them have their own importance. Seaborn is a Python data visualization library based on matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. In the world of analytics, the best way to get insights is to visualize. Because if you are in a position to visualize, at least half of the job is done. Data can be visualized by representing it as a plot, which is easy to understand, explore and grasp, such that helps in drawing the attention of the key elements. To analyze a set of data using Python, we make use of matplotlib, a widely implemented 2D plotting library. Likewise, Seaborn is a visualization library in Python. It is built on top of the matplotlib. Seaborn versus matplotlib. It is summarized that if matplotlib tries to make things easy and hard things possible, Seaborn tries to make a well-defined set of hard things easy too. Seaborn helps resolve the two major problems faced by matplotlib, and the problems are default matplotlib parameters working with data frames. Now, as Seaborn complements and extends matplotlib, the learning curve is quite gradual. If you know matplotlib, you are already halfway through this Seaborn. Important features of Seaborn. Seaborn is built on top of Python's core visualization library matplotlib. It is meant to serve as a complement and not a replacement. However, Seaborn comes with some very important features. Let's see few of them. The features which are very important and useful: built-in themes for styling matplotlib graphics, visualizing univariate and bivariate data, fitting in and visualizing linear regression models, plotting statistical time series data. Seaborn works well with NumPy and Pandas data structure. It comes with built-in themes for styling matplotlib's graphics. In most cases, you will still use matplotlib for simple plotting. The knowledge of matplotlib is recommended to take Seaborn's default plots. Environment setup: installing Seaborn and getting started. Steps involved in installation of Seaborn. Is very simple to install Seaborn, like using pip installer, which you might have used earlier also. To install the latest release of Seaborn, you can use pip install Seaborn, and then it will automatically install your Seaborn. For Windows, Linux and Mac, using Anaconda from HTTPS. You can download Anaconda and start using for downloading any other software like pip. Is a free software available with the SciPy stack. It is also available for the Linux and Mac. It is also possible to install the released version using conda. So the command is conda install Seaborn. Now, to install the development version of Seaborn directly from GitHub, that is also possible. You can go to the GitHub URL, github.com, then mwas.com/Seaborn, and then dependencies are considered the following dependencies. That means you must have your Python already installed. NumPy, SciPy, Pandas, matplotlib should be there. If not, you can always install it. Importing datasets and libraries. Importing libraries, let us start by importing Pandas, which is a great library for managing relational table format datasets. Seaborn comes handy when dealing with the data frames, which is most widely used data structure for data analysis. The following command will help you import Pandas, like Pandas for managing datasets. Import Pandas as PD. PD is and you can use any word, but then PD is a conventional character. Now let us import the matplotlib library, which helps us customize our plots. So matplotlib, from matplotlib import pyplot as PLT, and then we will import the Seaborn library with the following command, like import Seaborn as SB or any other words that you want to choose. Importing datasets. We have imported the required libraries. Now we will learn how to import the required datasets. Seaborn comes with a few important datasets in the library. When Seaborn is installed, the datasets downloads automatically. You can use any of these datasets for learning with the help of the following function. You can load the required dataset, load dataset, right? So you can get these kinds of screens. Now importing data as pandas data frame. Now we will import a dataset. This dataset loads as pandas data frame by default. If there is any function in the pandas data frame, it works in this data frame also. The following line of code will help you import the dataset. Like as is mentioned, remark Seaborn for plotting and styling. Import Seaborn as SB. df, that is data frame, is equal to sb.load underscore dataset, and then within bracket tips. Then print df.head, and then you will get the top 5 records of the data set, right? It is appearing in the on your screen. Now the above line of code will generate the following output, like all these index numbers are there, 0 1 2 3 4, total bill amount, then tip amount, then sex, with who was the person who was responsible to pay the bill, then smoker or non-smoker, day, whether it is a Sunday or Monday or whatever day, time, dinner or lunch, then size, number of people along with the main person, so 2 or 3 or whatever number. So then you can get this kind of this output. Now to view all the variables datasets in the Seaborn library, you can use the following command with the get dataset names function as shown below. Import Seaborn as SB, print SB dot get dataset slash names. So you will get all the names. Like the above line of code will return the list of datasets available as the following output. Like you enscombe, you attention, you brain, all those things will be there, and then you will get these kinds of things which these are all the datasets, and then this is the actual data which you are going to get on your screen, right? Now data frames store data in the form of rectangular grids by which the data can be overviewed easily. Each row of the rectangular grid contains values of an instance, and each column of the grid is a vector which holds data for a specific variable. This means that rows of a data frame do not need to contain values of some data type. They can be numeric, character, logical, or etc. Now data frames for Python come with the pandas library, and they are defined as two-dimensional label data structure with potentially different types of columns. Figure aesthetic. Visualizing data is one step. Further making this visualized data more pleasing is another step. So visualization plays a vital role in communicating quantitative insights to an audience to catch their attention. Aesthetics means a set of principles concerned with the nature and appreciation of beauty, especially in art. Visualization is an art of representing data in effective and easiest possible way. So that is why it has become so popular and so easy to understand. Matplotlib library highly supports customization, but knowing what settings to tweak to achieve an attractive end and anticipated plot is what one should be aware of to make use of it. Unlike Matplotlib, Seaborn comes packed with the customized themes and a high-level interface for customizing and controlling the look for Matplotlib figures. Example like this: import NumPy as MP, then from a matplotlib import pyplot as plt, def, that is sign plot, then flip is equal to 1. This is the code that you are going to use it. If you can understand, fine, otherwise you can try it yourself, and then you will see that the result will come as it is shown here. X is equal to np, that is your NumPy dot line space 0, 14, 100. So you can see that this is for the purpose of drawing these lines which you are showing on your screen. Now for I in range 1 to 5, plt dot plot x, np dot sin x plus I into 0.5, and again multiplication 7 minus I multiplied by flip. Flip is already given, right? So you can see that, you will once you give it and go for the plotting of this graph, that is sine plot, you are going to, and by plt.show will definitely give you this kind of a plot. You will see that this kind of a sine curve or sine plot is going to be presented to you on your screen. So this is how a plot looks with the default matplotlib, right? Then to change the same plot to Seaborn, now this is how this was done in the matplotlib. Now if you want to check the same plot in the Seaborn, use the set function like import numpy as np from matplotlib import pyplot def sine plot flip is equal to 1, then x is equal to np line space, same command, same codes which was there you have seen. For I in range 1, 5, plt plot x, np sine x plus I into 0.5 multiplied by 7 minus I, then multiplied by flip. And now you are going to import the Seaborn. So import Seaborn as SB, then SB dot set sine plot, and now you are going to plot the graph, that is plt dot show. So you will see that your graph will be something like that. So if you see the graph which was earlier made by this matplotlib, and in this the difference is not much, but the sharpness is definitely there. So the above two figures show the difference in the default matplotlib and Seaborn plot. The representation of data is same, but the representation style varies in both. That is the difference. Basically, Seaborn splits the matplotlib parameters into two groups: plot style and plot scale. Seaborn figures styles, like the interface for manipulating the styles is set style. Using this function, you can set the theme of the plot as per the latest updated version. Below are the 5 themes available, like a dark grid, white grid, dark, white, ticks. So this is how, these are the further enhancement of your graph. If you want, you can do that. Let's try applying a theme from the above mentioned list. The default theme of the plot will be dark grid, which we have seen in the previous example, like import numpy as np from matplotlib import pyplot def sine plot flip is equal to 1. Again the same code that you have seen earlier. X is equal to np dot line space 0, 14, 100, and for I in range 1, 5, and then plt again x dot x, np dot sine x plus I plus multiplied by 0.5, then multiplied by 7 minus I, and then multiplied by flip. Then import Seaborn as CB, and now you are going to use the white grid. So SB set style, white grid, and sine plot PLT show. So now in this case you will see that the background is absolute white. So the difference between the above two plots in the background color, that is the main difference. So these are the types of differences that you can make it, so that you can improve upon your graph. Now removing excess spines in the white and ticks themes, we can remove the top and right axis spines using the despine function. That means dspine function. So for example, you can see that import numpy as np, then again import from matplotlib pyplot as plt, again the same command. Then you go for the sb.set style white. Now earlier we had white grid, now we are having white only. Import Seaborn, of course that has to be done. Then sine plot, and now we are using despine. Earlier if you see that we have used the sine plot with white grid. Now you are going to see use this sb.despine plt show. So when you do this, execute this, you will see that there is no grid available, only whiteness is there, and the background is totally white, and of course your plot is looking much better. In the regular plots, we use a left and bottom axis only. Using the despine function, we can avoid the unnecessary right and top axis spines, which is not supported in matplotlib. Now this is the difference between the matplotlib and Seaborn. So like this, there are minor differences are there, but definitely it improves the getup or the way your graph is presented on your screen or when you will print it. Now overriding the elements, if you want to customize the Seaborn styles, you can pass a dictionary of parameters to the set style function. Parameters available are viewed using access style function. Example, import Seaborn as SB, print sb.access underscore style. This of course you have to write as a code, and then you may have the good code. Output would be something like this, because you are going to get the all the access dot access below, access dot edge color, access dot face color. So like that. So if you do that, you will see all these which are presented here as an output to that. Altering the values of any of the parameters will alter the plot style. So you can always, like, if you go back and see that import Seaborn as SB and print sb.access underscore style. So once you do that and execute it, you will get these kinds of output. So that, this is for your understanding, so that as and when you feel like using them, you can use them, right? Now the next example is that import numpy as np. Again, from the same plot, similar plot in fact. Import my pyplot as plt, def is sign plot, flip is equal to 1, x is equal to np, line space, again the same code which you have seen earlier. Import Seaborn as sb set style, dark grid, axis. Now here you are using axis below is false, sign plot, SB, despine, and plot show. So once you give this kind of a command, you will see that output would be now appearing like this. These are minor differences that you can see, but definitely it is up to the individual to see that which one he likes most and how he wants to present it. Scaling plot elements, we also have control on the plot elements and can control the scale of plot using the set context function. We have 4 preset templates for context based on the relative size. The contexts are named as shown: paper, notebook, talk, or poster. By default, context is set to notebook and was used in the plots above. Right? Now, import numpy as np from matplotlib, import pyplot as plt. Again, I think def sign plot flip is equal to 1. Again, the same code. And again the similar type of graph, but again with the changing, using a different kind of access. Now you can see that import Seaborn as SB and SB dot set style dark grid and axis dot axis below is false, and then sign plot and SB despine and then plot show. So you can see that these are minor changes or differences, but definitely it gives a different look to your graph. The output size of the actual plot is bigger in size when compared to the above plot. So when you do this, you can, it is up to the individual to decide that whether which type of plot he wants to finalize. Now there is another very useful thing is color palette. Color palette, or it plays an important role than any other aspect in the visualization. When used effectively, color adds more value to the plot. A palette means a flat surface on which a painter arranges and mixes paints. Now you must have seen when the building is painted or your house is getting painted or anything is painted, whosoever paints it, he has the flexibility of mixing the colors or making his own colors. He doesn't want to go with the traditional colors like red, blue, yellow, etc. He can make his own colors and then changes the background or foreground or individual picture or whatever he wants, he can use them. Likewise, you can also do that. So building color palette, you can make the color palette also. Seaborn provides a function called color palette, which can be used to give colors to plots and adding more aesthetic value to it, because it gives more beauty on your whatever graph or picture that you are making. Usage is seaborn.color underscore palette. Palette is equal to none, n colors or none, then the set is equal to none. So when you do that, you may get this kind of a color palette. Parameters, the following tables list down the parameters for building color palette. Now this is how you can make your color palette. And colors, the number of colors in the palette, and if none, the default will depend on how palette is specified. By default, the value of n color is 6. Desat proportion to the desaturate each color. So these are some of the fine things which you can use for the purpose of making your own color palette. Return refers to the list of RGB tuples. Following are the readily available Seaborn palettes like deep, muted, bright, pastel, dark, colorblind, and beside these one can also generate new palettes. So that is how you can, the more you want to practice, the more you want to go about it, you can definitely improve upon on making more and more colors as per your requirement. It is hard to decide which palette should be used for a given data set without knowing the characteristics of data. Being aware of it, we will classify the different ways for using color palettes types like qualitative, sequential, or diverging. So we have another function Seaborn pal plot which deals with the color palette. This function plots the color palettes as horizontal arrays. So this is how you can get it. Now, deep, bright, and dark you can see. So different, it's a very minor difference, but just you can definitely observe the differences in the different color palettes. Now, qualitative color palettes are qualitatives are categorical palettes are best suitable to plot the categorical data. Example, from matplotlib, import pyplot as plt, import Seaborn as sb, current palette is equal to sb.color underscore palette, and sb.palplot current palettes, and plt.show. So when you write this code, you will get this kind of a output. We haven't passed any parameters so far. Now we have not done any parameters. We have not passed any parameter. It is simple code. So in color palette, by default we are seeing 6 colors, and whatever the base colors are, all those 6 colors are in front of you. You can see the desired number of colors by passing a value to the n colors parameter. Here the pal plot is used to plot the array of colors horizontally. Now sequential color palettes. Sequential plots are suitable to express the distribution of data ranging from relative lower values to higher values within a range. Appending an additional characters to the color passed to the color parameter will plot the sequential plot. For example, from matplotlib import pyplot as plt, import Seaborn as sb, current palette is equal to sb.color palette, sb palplot sb color palette greens. Now here we have used the word greens. That means we want all the possible shades of green. And when we say plt.show, you will get this kind of a color palette. So we need to append s, because S means that you want to have if you simply give green, then only one will be appearing. But if you give greens, that means you want the various shades of the green color. Parameter like greens in the above example, right? So this is how you can do it. Now diverging color palettes, like diverging palettes use 2 different colors. Each color represents variation in the value ranging from common point in either direction. Assume plotting the data ranging from -1 to 1. The values from -1 to 0 takes one color, and 0 to +1 takes another color. By default, the values are centered from 0. You can control it with parameter center by passing a value. So you can see that, for example, from matplotlib import pyplot as plt, import Seaborn as sb, current palette is equal to sb.color palette, sb.palplot, sb.color palette, brbg, right, comma 7, and plot show. So br means brown and bg means brown and blue and green. That is how you can see the mix of all, and output would be something like this if you give that kind of a code. Setting in the default color palette, the function's color palette has a companion called set palette. The relationship between them is similar to the pairs covered in aesthetics. The arguments are same for both set palette and color palette, but the default matplot parameters are changed so that the palette is used for all the plots. So example is import numpy as np, from matplotlib import pyplot as plt, def sine plot flip is equal to 1, again the same code that we have seen earlier. Import Seaborn as sb dot set style white, sb dot palette is hus, and then sine plot, and then plt show. So you can see that this kind of a graph will be there on your screen. Now plotting univariate distribution. Now this is something which is very commonly used, that is distribution of data is the foremost thing that we need to understand while analyzing the data. Here we will see how Seaborn helps us in understanding the univariate distribution of the data. Function distribution plot, of course, provides the most convenient way to take a quick look at univariate distribution. This function will plot a histogram that fits the kernel density estimation of the data. So you can use seaborn.distplot, and this is the way you can histogram will be available to you. Parameters. The following table lists down the parameters and their description. So you can see that these are the details of the parameters, that is data, series 1D array, bins, specification, all these. The more you practice, you will get to learn more and more, and you keep on referring this as and when you feel like, you can definitely start getting more and more ideas. Now histograms represent the data distribution by forming bins along with the range of the data and then drawing bars to draw the number of observations that fall in each bin. Now for drawing a histogram, import pandas as PD, import Seaborn as SB. From matplotlib, import pyplot as plt, and then df is equal to sb.load. Dataset is iris here. Iris dataset you must have seen earlier also in various examples. sb.distplot, then df petal length, and kde is equal to false. So that means we are ignoring that, we are not going for it. plt.show, so when you go for that showing of the plot, you will see this kind of a plot available to you as a histogram. Now here kde flag is set to false. As a result, the representation of the kernel estimation plot will be removed and only histogram is plotted. Now that is why, because we have mentioned it as false, that is why you are getting this kind of a plot of the histogram, right? So these are the minor changes, but definitely it makes a lot of difference. What is KDE, kernel density estimates? It is very useful. Now KDE is a way to estimate the probability density function of a continuous random variable. It is used for non-parametric analysis. Setting the hist flag to false in this plot will yield the kernel density estimation plot like this. So import pandas as PD, import Seaborn as SB from matplotlib, import pyplot as PLT, and then df, of course, load dataset iris and SB distplot, df petal length, hist is false, that means you don't want histogram, and plt.show, and then you will get this kind of a line graph, curved line that you are seeing on your screen. Then fitting parameter distribution, this plot is used to visualize the parameter distribution of a data set. Now again, this is a similar type of code, that is import pandas, Seaborn, matplotlib, then dataset iris, and then distplot. Now here you are having you have not made it like KD is equal to false or anything of that sort. So whatever is the original thing that is going to come here, and you are getting a histogram along with a line also there. So that is how you will get the fitting parameter distribution, right? Now plotting bivariate. Now suppose you have bivariate, two variables are there. So bivariate distribution is used to determine the relation between two variables, and this mainly deals with the relationship between two variables and how one variable is behaving with respect to the other. The best way to analyze bivariate distribution in Seaborn is by using the joint plot function. Now joint plot helps you in defining or expressing the bivariate distribution in a very nice way. So we will see that also when we are going to, like joint plot creates a multi-panel figure that projects the bivariate relationship between two variables and also the univariate distribution of each variable on separate axes. Now for that, if we draw a scatter plot, so scatter plot is the most convenient way to visualize the distribution where each variable, each observation is represented in two-dimensional plot via x and y, right? So two-dimensional, you can easily represent it on a graph x and y on x-axis and y. Using x-axis and y-axis, you can draw a scatter plot. An example like import pandas spd, import Seaborn, then matplotlib, dfsb.load dataset as iris. Joint plot you are going to make now. X is equal to petal length, y is equal to petal width, data is equal to df, which you have already defined earlier, and you are going to show your graph. So when you plt.show, when you execute it, you will see that this kind of a graph will be appearing on your screen. So the figure shows the relationship between the petal length and petal width in the iris data. A trend in the line in the plot says that positive correlation exists between the variation under study. Why it is positive? Because you can see that the scatter plot is moving towards the right and going upwards. So that is why every point has its own importance and significance, and that tells us that how the relationship is there between the two variables. And because it is moving in the same direction and in upward direction, that is why they are positively correlated. Okay, now moving on to the hex bin plot. Now hexagon binning is used in bivariate data analysis when the data is sparse in density. That is, when the data is very scattered and difficult to analyze through scatter plots. An addition parameter kind and value hex plots the hex bin. For that, if we write this code like import pandas as pd, Seaborn as sb, matplotlib import pyplot, sb load data set is of course iris, joint plot x is equal to petal length, y petal width, data df kind is equal to hex. Now here we are defining kind as the kind of graph would be hexagon type, right? And data frame of course is that same which we have already defined, and then we are going to show the plot, the plt.show, and you will get this kind of a hex. The graph is known as hex bin plot. This kind of a plot will be there. Now kernel density estimation is a non-parametric way to estimate the distribution of a variable. In Seaborn we can plot a KDE using joint plot. Pass value KDE to the parameter kind to plot kernel plot, right? And once we do that, then with an example, let us understand that import pandas as pd, import Seaborn, matplotlib, sb.load dataset iris, joint plot x, petal length, petal width, data is df, kind is hex, and you will see that this kind of a graph is going to appear. You can see that earlier also we got, if you go see the earlier, this here also you have got this, and now you are again getting this kind of a graph using the kind as hex. So this is how you can make more and more useful graphs depending on your requirement. Now visualizing pairwise relationship. Now this is a very common and very useful, and it gives you details of all the variables. Whatever combination you want, you can get the kind of graph that you want. Like data sets under real time study contain many variables. In such cases, the relation between each and every variable should be analyzed. Plotting bivariate distribution for n, 2 combinations will be a very complex and time-taking process. To plot multiple pairwise bivariate distribution in a data set, you can use the pair plot. So pair plot is definitely, it makes graphs in pairs. That is why it is known as pair plot. This shows relationship for n, 2. That means combination of a variable in a data frame as a matrix of plots. You will get a matrix of plots. So you can imagine that how useful it would be. You can, in one graph only, you are going to get different kind of subgraphs with two individual variables being considered for that particular small graph. And the diagonal plots are the univariate plots. So that is how you can get the graphs. These are very useful and very interesting. Axis. In this section we will learn that what are axes, their usage, parameter, and so on. So usage is Seaborn pair plot type, and you can make the one color. Like here you are seeing single color. You can have different colors. You can change the colors as you feel like. Parameters here like following tables list List down the parameters of axis. Now data is data frame, hue is variable the data to map plot aspects to different colors, palette is set of colors for mapping the hue variable, kind is kind of plot for non identity relationship, and diag kind is kind of plot for the diagonal subplots. So these are the various parameters that can be used for the drawing the plots. Except data, all other parameters are optional. There are, because data has to be there. I mean, you can't ignore the data, otherwise what you are going to get. So there are few other parameters which pair plot can accept. The above mentioned are often used as parameters. Now example is import again pandas, then Seaborn, then import pyplot as plt, then your data set is iris, and then sb.set style ticks, and sb pair plot again you are going to get, and df hue is equal to species, whatever species that we have in this, you can get that, and then diag kind is kde, and then kind is equal to scatter. The kind of plot that you are going to get is a scatter plot, and palette is husp and plt show. So you can see that when you give so many parameters which we have seen earlier, you are going to get a very colorful, very useful graph as it is shown on your screen. Output may also be like this. We can observe the variations in each plot. The plots are in the matrix format where the row name represents x-axis and column name represents the y-axis. The diagonal plots are kernel density plots, where the other plots are scatter plots as mentioned, right? So you can see that beautiful graphs can be created with the help of this. Plotting categorical data, if you want, scatter plots, hexbin plots, and kde plot, which are used to analyze the continuous variables, are useful. But these plots are not suitable when the variable under study is categorical. When one or both the variables under study are categorical, we use plots like strip plot, swarm plot, etc. Seaborn provides interface to do so. So these kinds of graphs can also be created, and it may be a swarm plot, or maybe a strip plot, or something of that sort, which we are going to understand now. Categorical scatter plot. In this section we will learn about categorical scatter plots. A strip plot, like a strip plot, is used when one of the variables under study is categorical. It represents the data in sorted order along any of one of the axes, right? So this is the kind of graph you may get. Example: import pandas, import Seaborn, import from matplotlib, import pyplot, df again load data set as iris, strip plot, x is equal to species, y is equal to petal length, the data is df, and plt show. So when you go for this strip plot, you are going to get this kind of a line. Now see how fine graphs is available for different kind of species that you are getting, like Setosa, versicolor, and virginica. You can get these kinds of graphs. So the position and length and color, everything is so fine, and when it will be a bigger graph, you can see that how useful it would be. In the above plot, we can clearly see the difference of petal length in each species. But the major problem with this above scatter plot is that point on this scatter plot are overlapped. Now this is something which we can definitely look into. We use the jitter parameter also to handle this kind, so that you can see if you want to increase the the dots sizes and maybe slightly wider, you can use the jitter option also. Jitter adds some random noise to the data, and this parameter will adjust the positions along the categorical axis. So import pandas, spd, Seaborn as sb, matplotlib import pyplot, data set is of course iris, sb strip plot, species, y is petal length, data is df, and jitter is equal to true. It is true, it is not true, sorry, this is a mistake. Okay, the plt dot shows, when you show it, you will get this kind of a graph. Now the distribution of points can be seen easily. Swarm plot, another option which can be used as an alternate to jitter is function swam plot. Now we are going to have a swam plot. This function position each point of scatter plot on the categorical axis and thereby avoids overlapping points. Now import pandas as PD, import Seaborn as SB, then of course matplotlib, then dataset is iris, swam plot. Now instead of strip plot, now we are going to use swam plot. X is equal to species, Y is equal to petal length, and data is equal to DF and PLT show. So output is going to be something like this, which is a swam like. If you see, it is slightly, although the species are same, versicolor, and then Virginia and Chitosa, all the same species are there, but now you can see that they are in a different shape altogether, something like your butterfly. Distribution of observations. In categorical scatter plots, the approach becomes limited in the information it can provide about the distribution of values within each category. Now going further, let's see what can facilitate us with the performing comparison within the categories. So there's another thing which is a very useful plot like box plot. Box plot is a convenient way to visualize the distribution of data through their quartiles. Box plots usually have vertical lines extending from the boxes which are termed as whiskers. These whiskers indicate variability outside the upper and lower quartiles. Hence, box plots are also termed as box and whisker plot and box and whisker diagram. Any outlier in the data are plotted as individual points. In case there is any outlier, then it will print as an individual point. So this is the type of box plot that you can see. Example for this is like import pandas, Seaborn, matplotlib, dataset is again iris, swam plot that we want, and then plot show. So you can see that the box plot is going to be shown here. Type of box plot is going to be shown here, right? So this is how you can get this kind of the data. The dots in the plot indicate the outlier. If you see the dots, they are the outliers. There is another very useful plot, that is violin plot. Violin plots are combination of the box plot with the kernel density estimates. So these plots are easier to analyze and understand the distribution of the data. Let's use tips dataset called to learn more into violin. Why we are using? Because it's a tip, so it may when you visit the restaurant or any restaurant, the sale that they make is not uniform. It keeps on changing, and violent kind of a graph clearly shows that how this sale is happening. So the same graph can be presented here. So again, let's use tips dataset here, and now we can use the violin plot. So we are importing the pandas, Seaborn, matplotlib, and then dataset is tips is sb.violin plot. X is equal to day, Y is equal to total bill. One day means which day, Sunday, Monday, Tuesday, or this is the total bill amount, and data is for data frame, that is data set tips. And then when you are going to show the PLT plot show, you are going to get this kind of now this is for 4 days data, right, from Thursday, Friday, Saturday and Sunday. So 4 days data is there, and that is why this tells you that how the sale has happened on these days. Now the quartile and whisker values from the box plot are shown inside the violin. As the violin plot uses KDE, the wider portion of violin indicates the higher density, and narrow region represents relatively lower density. The interquartile range in the box plot and higher density portion is in KDE fall in the same region of each category of violin plot. The above plot shows the distribution of total bill on 4 days of the week, but in addition to that, if you want to see how the distribution behaves with respect to sex, that means how many males and females have visited. The import pandas as PT, import Seaborn, then matplotlib, then do load data set, tips, SB violin plot, X is equal to day, Y is equal to total bill, hue is equal to sex, because that is what we want to have the difference. Data is equal to DF and PLT show. So you can see that for every day now you are getting how many males, how many females, how many day males, how many females. That is a further information that you are getting about your data set. Now we can clearly see the spending behavior between male and female. That is what our objective was. We can easily say that men make more bill than women by looking at the plot. And if the hue variable has only two classes, we can beautify the plot by splitting each violin into two instead of two violins in a given day. Either part of the violin refer to each class in the hue variables. So import pandas, Seaborn, matplotlib, data is of course tips. Type of graph is violin plot, sb.5 violin plot, x is equal to day, y is total bill, hue is equal to sex, data is df, and then when you show this, print this or a graph, then you will get this kind of. So in one violin graph only, you are getting the data for both, that is male and female both, right? So this is the way you can present your graph, violin graph, in depicting both the sexes, that is male and female, in one graph only, right? Then coming to statistical estimation. In most of the situations, we deal with the estimation of the whole distribution of the data. But when it comes to central tendency estimation, we need to specify a way to summarize the distribution. Mean and median are the very, very often used techniques to estimate the central tendency of the distribution. Now, in all the plots we have seen so far, we made the visualization of the whole distribution. Now let us discuss regarding the plots with which we can estimate the central tendency of the distribution. So bar plot is of course one very common plot. The bar plot shows the relation between the categorical variable and the continuous variable. The data is represented in rectangular bar where the length, the bar represents the proportion of the data in that category. Bar plot represents the estimate of central tendency. Let us use the Titanic data set to learn bar plots. Now here we are going to use another type of data set, that is Titanic. Titanic we have used in our earlier examples, and the same data set where a ship was drowned in 1911, the same data set has been used here also for the purpose of depicting in the form of a graph, bar plot. So import pandas as PD, Seaborn, matplotlib, and now the data set is Titanic, that is the data frame, SB bar plot, x is equal to sex, y is equal to survived, hue is equal to class, and data is equal to df, and PLT show. You must be very particular about how the various commas or brackets are being used, or single quote or double quote or commas or equal sign. All these things are very important in Python. So whenever you write the program, you must be very particular about noting it down, as to what kind of a punctuation sign, that is comma or this or inverted commas, are being used. And once you plot this, when you execute this particular code, you will get this kind of a bar plot, right? Now in the above example, we can see that the average number of survivals of male and female in each class. From the plot, we can understand that the more number of females survived than males. In both males and females, more number of survivals were from the first class. The special case in bar plot is to show the number of observations in each category rather than computing a statistic for a second variable. For this we use count plot. Now you can see that just by looking at the graph, you can make out your inferences, that how many people died or survived, how many various details you will get just by looking at the graph, different graphs. So import pandas, SPD, Seaborn, matplotlib, and dataset is of course Titanic. Count plot. Now we are going to have the count plot. So class, then data, then palette is equal to blue, as that is why you are seeing the blue color on your screen, and then plt.show. So when you execute it, you will see the plot says that the number of passengers in the third class are higher than first and second class. Now just by looking at the graph you can immediately see that yes, the number of people in the third class are more than the first and second class. Now point plot. Point plot is same as bar plots but in a different manner. Rather than the full bar, the value of the estimate is represented by the point at a certain height on the other axis. Now here for this we are using again the similar code, import pandas, Seaborn, matplotlib, dataset is again Titanic. Point plot we are using, so x is equal to 6, y is survived, hue class, and data is equal to df. Now because we are using the point plot, you are getting the graph like this, right? And once you have a on a bigger full-blown screen, you will get complete details and you can understand just by looking at the graph itself. Now plotting wide from data. Now it is always preferable to use a long form or a tidy data set, but at the same time when we are left with no option rather than to use a wide form data set, same functions can also be applied to a wide form data in a variety of formats, including pandas, data frames, or two-dimensional NumPy arrays. These objects should be passed directly to the data frame. The x and y variable must be specified as strings, and now the code could be written like this, like import pandas as pd, import Seaborn, matplotlib, data set is iris now, and box plot data is equal to df. Orientation is horizontal. Now why it is horizontal? Because we want it like that. That is why the graph that you are seeing also is oriented towards the horizontal. And plot show, so you will get the box plot like this, horizontally oriented. Now additionally these functions accept vectors of pandas or a NumPy object rather than variables in a data frame. An example is import pandas as pd, import Seaborn, import matplotlib, data set is iris here again, then data box plot, data is equal to df, orient is equal to h, that is horizontal again, and then plt show, so you are again going to get this kind of a plot. The major advantage using the Seaborn for many developers in Python world is because it can take pandas data frame object as parameter. That is one very big difference. Okay, now multi-panel categorical plots. Categorical data can be visualized using two plots. You can either use the functions point plot or the higher level function factor plot. Now factor plot draws a categorical plot on a facet grid. Using kind parameter we can choose the plot like box plot, violin plot, bar plot, and strip plot. Facet grid uses point plot by default. Now the code for that is import pandas as pd, Seaborn, matplotlib, sb.load, and the data set is exercise here. Now exercise is the data that we have worked when if you have gone through the data visualization exercise, you would have seen this. Otherwise we are going to do that again. sb.factor plot, time, pulse, hue is kind, data is equal to df, and then plot show. So when you go this, do and execute this code, you will get the output like this. We can use a different plot to visualize the same data using the kind parameter. Now that is again a very important thing and very useful, that the same data set you can use for making different plots, and you can see that which one is more useful for you. So you can make use of that. Import pandas as pd, Seaborn, matplotlib, then data set is exercise, factor plot is x is equal to time, y is equal to pulse, hue is kind is equal to violin, and data is df. And then when you print it or execute it, you will get this kind of a graph. In factor plot, the data is plotted on a facet grid. That is the difference, because we have used that factor plot, so it is using the facet grid, right? Now what is a facet grid? Let's try and understand that also. Facet grid is a matrix of panels defined by row and column by dividing the variables. Due to panels, a single plot looks like multiple plots. It is very helpful to analyze all combinations in two discrete variables. Let's visualize the above definition with an example. Now import dataset like pandas, Seaborn, matplotlib. Dataset is of course exercise, factor plot, and then again time y is equal to pulse, hue is kind is equal to violin, of course, and then data is data frame, and then execute the plot, that is plt.show, and you will get this kind of a plot. Now you can see that all those when you are doing the exercise, these are the three factors: rest, walking, running, and this is the 1 minute, 15 minutes, 30 minutes. The complete details you are getting here. Diet, no fat, diet is equal to low fat, and these are the different pulses also details are given to you. The advantage of using facet is we can input another variable into the plot. The above plot is divided into two plots based on a third variable called diet using the column parameter. So you can see that in one graph itself you are getting two different graphs, one with the no fat and the other with low fat, and again different with different parameters, so that you can easily compare. It becomes easier for anybody to just look at, and at the same time you can look at two different graphs and make your own comparisons and of course inferences. So we can make many column facets and align them with the rows of the grid, like import pandas SPD, Seaborn, matplotlib. Dataset is Titanic again now, and factor plot, that is alive is equal to column dec, column wrap 3, data again, and df, and dec not null, kind is equal to count, and then you execute it, then you can get this kind of a bar graph, right? Now linear regression. Now linear regression is very important application, particularly in data analysis. Most of the time we use data sets that contain multiple quantitative variables, and the goal of an analysis is often to relate those variables to each other. This can be done through the regression lines. While building the regression models, we often check for multi-collinearity, where we had to see the correlation between all the combinations of continuous variables, and will take necessary action to remove the multi-collinearity if it exists. In such cases, the following techniques help. Functions to draw linear regression models. There are two main functions in Seaborn to visualize a linear relationship determined through regression. These functions are regplot or implot, right? Regplot versus implot. Regplot accepts the x and y variables in a variety of formats, including simple numpy array, pandas, series objects, or as references to variables in a pandas data frame. Implot has data as a required parameter, and the x and y variables must be specified as a string. This data format is called long form data. That's the basic difference between the two. Now let's draw the plots. For example, plotting the reg plot and then implot with the same data. So import pandas, Seaborn, matplotlib, dataset is tips. Regplot is equal to sb.regplot is equal to x is equal to total bill, y is equal to tip, data is equal to df. sb implot, x is equal to total bill, y is equal to tip, data is equal to df. So both the plots, regplot and implot, both are being printed here, and when you execute it, you can see the difference between the sizes of the two plots. So you can see, just by looking at that, you can definitely make out. You can also fit a linear regression when one of the variables takes discrete values. So you can easily now understand how the various data points are distributed along the line. So that is the advantage with this. An example for this: import pandas as PD, Seaborn, matplotlib, then dataset is tips, implot is size is equal to x is equal to size, y is tip, data is equal to df, and plt show. So when you execute that, you will get this kind of a graph. Fitting different kinds of models. The simple linear regression model used above is very simple to fit, but in most of the cases the data is non-linear, and above methods cannot generalize the regression line. Let us use Anscombe's data set with the regression plots. Example: import pandas as pd, seaborn as sb, matplotlib import pyplot as plt, and then your data set is going to be anscombe. Now you can describe it as a data frame, then sp implot x is equal to x, y is equal to y, data is df query, and then data set is equal to I, and then when you execute it, you are going to get this kind of a line graph. In this case, the data is good fit for linear regression model with less variance. So let us see another example where the data takes high deviation, which shows the line of best fit is not good. So now again, using the same example, and importing the pandas, seaborn, matplotlib, and data set is anscombe, and then implot x is equal to x, y is equal to y, data is df dot query, data set is equal to L, and then output you are going to get as this line. The plot shows the high deviation of data point from the regression line. Such non-linear higher order can be visualized using the implot and regplot. These can fit a polynomial regression model to explore simple kinds of non-linear trends in the data set. So you can see just by looking at the graph itself, you can make out whether they are linear or they are non-linear. You can see that how it is changing. Now another example, like import pandas, spd, seaborn, matplotlib, and then data set is anscombe, and then again implot x, and you can see that how the curve that you are getting non-linear you are getting in this particular plot when you execute this particular code. Then facet grid is a useful approach to explore medium dimensional data is by drawing multiple instances of the same plot on different subsets of your data set. This technique is commonly called as a lattice or trellis plotting, and it is related to the idea of small multiples. To use these features, your data has to be in pandas data frame. You can see that is something which you have to keep in mind. Plotting small multiples of data subsets. Earlier we have seen the facet grid example where facet grid class helps in visualizing distribution of one variable as well as the relationship between the multiple variables separately within subsets of your data set using multiple panels. Now facet grid can be drawn with up to 3 dimensions: row, column, and hue. These first two have obvious correspondence with the resulting array of axes. Think of the hue variable as a third dimension along with the depth axis where different levels are plotted with the different colors. So you can see that different boxes are shown with the different colors. That is because it is helpful and it is possible, and we can create this kind of a colorful plots. So facet grid objects takes a data frame as input and the names of the variables that will form the row, column, or hue dimensions of the grid. The variables should be categorical, and the data at each level of the variable will be used for a facet along with that axis. Example is import pandas, then seaborn, matplotlib, and then data frame is tips. Then the facet grid is df, column is equal to time, and then plt show. So when you execute this, you will see this kind of a graph. It is not showing actually anything, but definitely it's a kind of a structure or a frame. In this example, we have just initialized the facet grid. This is just the initialization of that object which doesn't draw anything on them, right? So that is why it is shown like this only. Now in the next, the main approach for visualizing data on this grid is with the facet grid dot map method. Let us look at the distribution of tips in each of these subsets using histogram. Now import again the same pandas, seaborn, matplotlib, data set is tips, facet grids df, column is equal to time, and then gmap plt dot hist tip. Then again when you execute this code plt dot show, you will see that number of plots is more than 1 because of the parameter column, because we are having parameter column here, like time. So here you can see in one, because in the same day there are 2 timings, lunch and dinner. So We want to see the comparison between the two, that how the restaurant is performing during lunch and the dinner time. That is what the purpose. Now, to make a relational plot, pass the multiple variable names, import again the same dataset. Pandas, Seaborn, matplotlib, dataset is tips, facet grid is, again now we are looking for the sex difference, and the smoker and non-smoker also. Then again, and this G map PLT scatter, and then total bill tip, and then you execute it, and you can see that now you are going to get the between the lunch and dinner, what is the difference between the sex and the smokers. Right now, here we are going to get the pair grid. Pair grid allows us to draw a grid of subplots using the same plot type of to visualize data. Unlike facet grid, it uses different pair of variables for each subplot. It forms a matrix of subplots. It is also sometimes called as a scatter plot matrix. So you can see that its scatter plot is also visible. The usage of pair grid is similar to the facet grid. First, initialize the grid and then pass the plotting function. Import pandas as PD, Seaborn, matplotlib, dataset is iris, pair grid is df, and then gmap is plt scatter, and then execute the code. So you will get this kind of a matrix grid of plots. It is also possible to plot a different function on the diagonal to show the univariate distribution of the variable in each column. So you can see how beautifully the graph has been presented and giving different sets of parameters. Example again, like import pandas, Seaborn, matplotlib, then iris dataset, pair grid, then gmap dialog plt.hist, and then again going for the off diagonal plt scatter, and then execute the code, and you can see that this kind of a graph is going to appear with this kind of a code. Now we can customize the color of these plots also. If you want, you can make the changes in the color. The data is same, the code is same, everything is same. The data set has 4 measurements for each of these 3 different species, and you can see this here that import pandas, Seaborn, matplotlib, all these have been imported. Dataset is iris, pair grid is df, plt.hist, that is diagonally, and cmap off diagonal, and when you execute it, you can see that how the colorful graph is appearing. Just to beautify, all these things are possible with your minor changes in the code. Here again, like we can use a different function in the upper and lower triangles to see different aspects of the relationship. Now again, the same importing, that is pandas, Seaborn, matplotlib, then dataset is iris, pair grid, the type of data plot that we want, then upper and lower, of course, scatter plot and KD plot, CMap is blue, here you can see, and then KD plot is equal to line width is 3, legend is equal to false, and when you show that, you can see that pink and blue both are appearing as per our code that we have written here. So you can see all these changes for our own understanding and better presentation. We can do all this. So this completes our Seaborn, which is a very, very useful library available with Python, and people are using it quite extensively for various purposes. Thank you.